Alright, so again we're in chapter 4, section 2 on home loans. So we're going to look at another problem. This is example 11 from your notes. An $80,000 home loan was obtained for 20 years at 6% interest compounded monthly. If the monthly payment is rounded up to $600, what is the term of the loan and what is the size of the concluding payment? So here we're using the stuff from previous. Now if you want to find the monthly payment you can, but in this problem we don't necessarily need to. All we need to know is that if it should be smaller than 20 years. Okay, so if we're doing, set up our timeline here, 80,000 and we're making $600 payments on it each month. And we know 20 years should be down here, and this is going to be our last payment. And then we'll have the one smaller payment 1 month later. That's what we're trying to find, okay? So we're trying to figure out this one and this one. We have to find both, which is really a 4.1 problem. So again, here we just know this 20-year piece tells us that this should be less than 20 years, okay? So just so we have an idea, kind of a ballpark of what we should be doing here, our n for this piece would be 12 times 20, which would be 240. So if we don't get an n smaller than 240, something went wrong, because we're rounding up the payments here, okay? Rounding up the payments. So then we know that a 240 would be our 80,000. And then we have our interest rate at 6%, so that'd be 0.06, and it's monthly. So that means our I is 0.06 over 12. Okay, and again, we're trying to figure out the exponent. Okay. So again, the exponent we find should be smaller. Okay, if it's not, something went very, very wrong. To find n, okay, so we have $80,000 is equal to 600 times 1 minus 1 plus 0.06 over 12 to the negative n all over 0.06 over 12. And again, the reason we're subtracting 1 minus is because this is an a sub n problem, okay, a sub n. Look at your formula sheet, make sure you're using the right formula. First step is we have to get this giant fraction alone, so we're going to divide by 600. To make our lives easier, I'm going to cancel out some of the zeros, so we really have 800 over 6. And that's equal to our fraction. Okay, now we want to get rid of the denominator, so I'm going to multiply by the denominator on each side. So then over here we're just left with the numerator 1 minus, and then parentheses 1 plus 0.06 over 12, and parentheses to the negative n. And again, we're trying to find n. So now that we have the numerator alone, we have to get the piece that's in parentheses and raised to a power alone. So we have to move the 1 over to this side. So we do 800 over 6 times 0.06 over 12 minus 1 equals negative 1 plus 0.06 over 12. To the negative n. So now we want to get rid of that parenthesis, that negative sign. So I'm going to take a different color and I'm going to flip them so that I know for my own sanity that I did it. Okay, and now we do the natural log. So we're going to do the natural log of this side and the natural log of this side. Natural log tells us we can pull the power down. So now we have the natural log of 1 minus 800 over 6. So again, I just switched positions here just to make it a little easier to write. 0.06 over 2 equals negative n times the natural log of 1 plus 0.06 over 12. So we're going to take this number and we want to isolate it, so we're going to divide by the negative and by the natural log. So then n would be the opposite of the natural log of 1 minus 800 over 6 times 0.06 over 12 divided by the natural log of 1 plus 0.06 over 12. And entering that mess into the calculator, Make sure that if you use any extra parentheses in here, make sure that you close and end the natural log ones before you start the next piece, because you want the natural log of that and then divided by the other natural log. If you mess up those parentheses, your answer will be way off. So we get 220.27. So that means we're going to have 220 full payments of $600 and then one smaller payment. So now we're going to find the smaller payment. Okay? So that means that our smaller payment is going to be smaller than 600, because when we just see concluding payment, we're assuming 1 month later, or one payment period later. In this case, it's 1 month. So now we're going to take 80,000 times 1 plus our I, 0.06 over 12, to the 221 minus 600 times 1 plus 0.06 over 12, to the 220 minus 1 over 0.06 over 12, times 1 plus 0.06 over 12, to the 1. Okay, so this is your whole bit, right? This is our SN due, so this is really formula 4.2, because again we're doing 1 month later than that last payment's made. So when we plug that in, just gonna hide some of it just so we can get it up here. So we got 80,000 times 1 plus 0.06 over 12 to the 221, because again we're one payment period after that last full payment of 600 is made, minus 600 times, so this is for my numerator, this one is for my 1 plus. So I finished my numerator. Again, you have to be careful with your parentheses here because you don't want to accidentally do something. So we get $163.08, and you could round it to 9 if you wanted to. But again, it's going to depend on the lending party whether they consider that fraction, that small fraction of a penny, worth charging or not. So then our final answer here would be 220 full payments of $600 and a smaller payment of $163.08. That's your final answer here. Okay, so again, this is just incorporating everything that we talked about in the last section.